Populations and Resources Unit, Lesson 1.3, Births and Deaths in Populations. Activity 2, Birth and Death Token Model. Investigation question. How do births and deaths in a population affect its size? Do you think any meerkats would have been born during 2000 to 2016 when the population size was not changing? Yes, there are always births in a population. Do you think that any meerkats would have died during that time range? Yes, there are always deaths in a population. Do you think that all of the same meerkats were in the population during that time range? No, because some must have been born and some must have died. We are trying to understand why populations, like the glacier sea moon jellies, change size. We know that the births and deaths are always happening in a population, and today we are going to investigate the effect of births and deaths on the size of a population. We will conduct the birth and death token model activity. The token model population circle sheet contains a circle. This circle represents the population. A cup of tokens will represent individual organisms. You will start with 14 tokens in the circle, which represents 14 organisms in the population. In this model, you will add tokens to the circle to represent births and take tokens away from the circle to represent deaths. Using this model, you will complete 3 missions: getting the population to stay the same, increase, and decrease over time. Like in a real ecosystem, some organisms must die and some must be born every year, but you get to decide how many are born and how many die. You will choose between 1 to 3 births and 1 to 3 deaths per year. You will get sheets with these same tables and graphs on them. At the end of each round, you will need to keep track of what you did. Each round represents 1 year. Let's say for the first round, I decided on 3 births and 2 deaths. On the table under year 1, I would record 3 for the number of births and 2 for the number of deaths. Since I started with 14 organisms, my number of organisms after year 1 would be 15. How to graph the results. There is a dot showing that the starting number of organisms is 14. For year 1, you would put a dot showing the number of organisms is 15. You should also connect each dot. Students, complete the 3 missions. You have a Google Slides version of the tokens in Classroom to keep track of your missions. When you made the population size stay the same, how did the number of births compare with the number of deaths? The number of births was the same as the number of deaths. When you made the population size increase, how did the number of births compare with the number of deaths? The number of births was greater than the number of deaths. When you made the population decrease, how did the number of births compare with the number of deaths? The number of births was less than the number of deaths. During this activity, you also produce line graphs. This is a common way for ecologists to show data about populations. We will look at some line graphs from the glacier sea ecosystem in later lessons. How are the 3 graphs different? You should notice that when a population stays the same size, the line is relatively flat. When the population is increasing, the line goes up, and when the population is decreasing, the line goes down. Stability, when something stays mostly the same over time. Change, when something becomes different over time. Remember to look at the glossary if you need more support. Students, play the video. The video showed liquid being added to a system. What adds organisms to a population? Births. In the video, liquid was also removed from the system. What removes organisms from a population? Deaths. How would you expect the number of births to compare to the number of deaths in a population that was changing? The number of births would be greater or less than the number of deaths. They would not be equal. How would you expect the number of births to compare to the number of deaths in a population that was stable? The number of births would equal the number of deaths. If a population is stable, does that mean there are no births and deaths? No, births and deaths are always happening in a population. How is this idea represented in the video? The video showed liquid being added and removed from the tank, even though the amount of liquid in the tank stayed the same. Key concept, stability and change. A system can be stable even as things are being added to and removed from it. If the amount being added and being removed are not equal, then the system will change. Key concept. If the number of births and deaths at a given time are equal, then the population size will be stable. If there are more births than deaths in a given time, then the size of the population will increase. If there are fewer births than deaths, then the size of the population will decrease. The video used the example of liquid in a container to show that for a system to be stable, the amount of something being added to it needs to be equal to the amount being taken away. Similarly, we learned in the token model that if births and deaths are equal during a certain time range, the population will stay the same or stable. If births or deaths change, then the balance is disrupted and the population will change. If there are more births than deaths, then the population will increase. If there are fewer births than deaths, then the population will decrease. End of activity.